Well, so again, we are continuing with the oscillations and simple harmonic motion. And our today's discussion is related to spring pendulum. So, spring pendulum is not a different thing. In this case, we basically consider a spring and then we adjust the spring in the different arrangements. Like we can take a horizontal spring. When we take horizontal spring and connect it to the mass, we stretch the mass and leave, we find that the mass begins to oscillate horizontally into and fro motion. That is, again, the oscillatory motion is produced. Similarly, if the spring is considered in a vertical position and mass is suspended, then that mass has got the weight. Due to weight, the spring will be stretched downward, and if we apply some additional force and leave, again, the spring will begin to move into and fro motion, that is oscillatory motion. Now, another thing is spring pendulum means that an object is connected to spring either horizontally or vertically, and then that particular mass is allowed to be stretched, or we stretch that particular mass horizontally or vertically. When we take the horizontal displacement, it will be represented by x, whereas if we take it in vertical position, the vertical displacement will be taken as y. Now, spring will follow the same rule as that of the oscillatory motion. Like earlier we have discussed, for oscillatory motion, we find that as the displacement goes on increasing, or as the displacement goes on increasing, the restoring force will also increase, and the direction of restoring force and the displacement will be opposite. Displacement is always away from the mean position, and restoring force is always towards the mean position, and mean position is also known as the equilibrium position. So, whenever we make a relation between f and y or f and x, we should normally say that f is proportional to y if it is vertical motion, but if it is horizontal, then f is proportional to x. Now, when we remove the proportionality sign, we write a negative sign. So, either f will be equal to minus ky vertically, or f will be equal to minus, that is, kx horizontally. So, negative sign will indicate that direction of restoring force is always towards the mean position or equilibrium position, and displacement is always away from the mean position, whether it is horizontal displacement or it is vertical displacement. Moreover, K stands for spring constant and it is force per unit displacement. And whenever we write force, we can take it as mass into acceleration, and acceleration can be written as d square y over dt square, or it is d square x over dt square. So these facts are to be used in the spring pendulum. Sometimes we arrange the pendulum, spring pendulum, in series, and sometimes many springs are connected in parallels or in the multiple technique. So now we come to the main context. So in the main context, we have taken into consideration, let one end of an elastic spring be connected to rigid end and other to mass m. The system is placed on a frictionless horizontal surface. When mass is slightly pulled and left, then a restoring force is produced due to elasticity of spring. So this is what indicated in figure, that m is a mass and there is a spring, and the spring constant of the spring is taken as k. We know that spring constant is force per unit displacement. It can be horizontal displacement x or it can be vertical displacement y. But in this particular case which we are discussing, that will be a horizontal spring. It is connected to a rigid support and mass is connected to another end. So we have always to remember that whenever we stretch a spring, the displacement increases, and that will be directly proportional to the restoring force. Another thing is we have to remember that the cause of the um, that is cause of this force or restoring force is elasticity and inertia of the medium. That is, every medium has got elasticity and inertia, and that is the cause of generation of restoring force. So, as I have explained earlier, restoring force F is equal to minus kx. That is the horizontal displacement. Then force can be written as mass into acceleration, and acceleration is taken as according to derivative, that is d square x over dt square. We can remember always that the derivative of velocity is acceleration, or double derivative of displacement is also known as acceleration. It is a second degree equation. So force can be replaced by mass into acceleration, and acceleration is taken as d square x over dt square. And in all, this number will become minus kx. That is, m into d square x over dt square is equal to minus kx. Here k is the spring constant and x is the horizontal displacement, and negative sign is indicating that direction of the restoring force and that of displacement is always opposite. But if we wanted to find the magnitude, we can take the modulus of minus kx, and the magnitude will always be positive. So the point to remember, that is for every vector, if we take a modulus, then it will become the magnitude of that particular vector. Now, we will calculate acceleration, that is d square x over dt square, and that will become minus k over m into x, where x is the displacement and m is the mass of the oscillator, or we can say m is inertia factor. Then its unit will be obviously kilograms. Now we can estimate d square x over dt square, and it will become minus omega square x. Now minus omega square x and minus k over m into x will be equated, and our equation will become omega square is equal to k over m, and then we take the that is the square root. So square root when we take, omega will become k over m, and omega can be replaced by that is 2 pi n, and from that we get equation n is equal to 1 over 2 pi under root k over m. We know the value of n, and t is inverse to n, so we can write t is equal to 2 pi under root m over k. M is the inertia factor and k is the force constant. T is the time period of the spring pendulum. N is 1 over 2 pi under root k by m. We have taken a inverse type of equation. N is frequency of the harmonic oscillator, or the that is a spring pendulum, and that is 1 by 2 pi under root k over m.